Hello, can you hear the ringtone? Hello?
We can hear you, Professor.
Okay.
I can hear you.
Good, thank you. Good morning, everybody.
Good morning, Professor.
Morning, Prof.
Morning, Prof.
Morning, Prof.
Okay, Majesa, Shivar, thanks. Nice to see you. Yeah. Who helped me last time? Was it Michael or Shivar?
It was me, Prof.
Okay. You don't mind taking on the task again today, Shivar?
No problem, Prof.
Okay. So Shivar, everybody will check the chat column and pose any questions that are raised there whenever I ask for it. So he will handle that part of the program. Well, welcome everybody. Nice to have you back again on a Saturday morning. Not the best time to have a class, but nonetheless, it's a time when I think most of us are free. I'm happy to see we've got a regular group here. Some of you have been attending all the sessions. I'm not sure how many sessions we've had. I think this is the third one. And I hope you are benefiting from these little encounters or conversations. All right, without much further ado, let us start. As usual, we might just get cut off, which means that my 40 minutes is up. And you can have a break for 5 minutes. And I'm going to start precisely 5 minutes after we stop. So please make sure you come back, otherwise you will miss a small part of the next problem. Okay, so let's go. Today we are continuing Well, actually, we finished the 2018. It took us 2 weeks to finish that. And we are now doing the 2019 paper, the senior second round. So like before, we probably will take 2 meetings to finish this. And thereafter, I would take selected problems from other round 2 competitions and discuss them. So the first few problems, as we saw, will be quite easy. Let me just check that my recorder is on. I want to record these sessions so that if it's necessary, we might have to send the recording to people. What is this? Just one moment, please. Yeah, okay. Okay, sorry about that. Now we're going to go on to the first problem. The first problem, as usual, it's a very simple problem. The temperature in Bloemfontein rose from -4 to 8 in the afternoon. How many degrees did the temperature rise? It's just 4 plus 8. 4 up, another 4 up, 8 up. Or otherwise 8 minus -4. So it went up by 12 degrees. The second problem, a party wins 30% of 400 seats. How many seats do they have? 30% of 410 is that's 3/10 or 400. Otherwise, 30 over 100 or 400 is 30 times 4. The hundreds will cancel. 100 cancel with that 4 times. 30 times 4 is 120. And this problem, I once read this problem somewhere, and it came up in the context of somebody was writing on criteria that employers sometimes use to test the people who come for their interviews. And this is one of the questions some employer asked the person who was being interviewed. If 6 cats catch 6 rats in 6 minutes, how many cats are needed to catch 12 rats in 12 minutes? Now, I would imagine that some people who don't think too much will immediately say 12 minutes, obviously, without thinking that the employer would not ask this question if it was such a straightforward answer. All right, so those who actually think about it would say, well, if 6 cats catch 6 rats in 6 minutes, you have to imagine the situation. And I've drawn a little diagram here. Now, there's a cat, it's catching a rat. Cat, 6 cats catching 6 rats. In 6 minutes, this happens in 6 minutes. Now, if I increased the number here to 12, each of those will catch a rat. Again, it'll be in the same time, 6 minutes. Right? One cat will take 6 minutes to catch 1 rat. This one here will take 6 minutes to catch its own rat. This will take 6 minutes, and you put them all together, doesn't really matter. So you got 12 cats now, and you want to know in 12 minutes. I think that's the question. In 12 minutes, how many cats are needed to catch 12 rats in 12 minutes? Now you got more time. You got 12 minutes. So each cat will be able to catch 2 rats in 12 minutes. So how many cats will be needed to catch 12 rats? This will catch 12, 2, 2, 2, 2, 2. You've got 12. You'll still need 6 cats. All right. So it's not difficult, but it's just obvious. One cat will catch 1 rat in 6 minutes. 12 cats will catch 12 rats again in 6 minutes. Just line them up, right? If you're halving the number of cats, then it's going to take a longer time because you've got fewer cats. So it took 6 minutes in the first case. So this time it will be doubled. All right. So there is a kind of an inverse ratio here. So it's inversely proportional, not directly proportional. Okay, this is a problem on indices, and the trick is quite simple. Whenever you got an exponential problem, this is a problem on exponents, you bring everything to the same base. Well, you can make 2 to the power of n your subject straight away, divide by 4, and then you got 64 on the side. So you got 2 to the n is equal to 64. You might know immediately that 2 to the power of 6 is equal to 64. And you can say n equals 6. Otherwise, you can say 2 to the n equals 64, and 64, write it as a power of 2. That is 2 to the power of 6. That is the best way to do it. So okay, this is another way of doing it. I came to 2 to the n equals 64 and write 64 as 2 to the power of 6 in that case. And so therefore n will be equal to 6. If the bases are the same, you can equate the exponents. That's the principle. When the bases are the same, the exponents can be equated. So you have 8 equals 2 plus n, and solve for n. So that's the only condition in exponential equations. If the bases are the same, then the exponents are the same. So you bring it to the same base. All right, here you got a geometry problem. You got a triangle, and one of those sides is extended, and you've got that you got the measure for P. You know what the angle P is, that one, and R, that one, you know that as well. So you know that and that. And it's also given that PQT equals TQS. Now, what does this mean? If these 2 angles are equal, it's another way of saying that this line here, it divides this angle here into 2 equal parts. So therefore, it bisects the angle. This angle bisects this angle. All right, so the question is, what is the size of angle PQT? So you want to know what the size of this B-shaped angle is. All right. Okay, obviously this is a very, it uses very elementary principles. Most people run to work out the angles of a triangle. They know if you add the angles of a triangle, the answer is 180 degrees, regardless of how big or how small or how wide the triangle is. The sum is always the same. But very closely allied to that is the exterior angle theorem, which says that the exterior angle of any triangle, what do you mean by exterior angle? You take any one side and extend it, like the way we do here, RQ, and you extend it. The new angle formed as a result of extending it, and that will be this angle here, PQS, and that is called an exterior angle. The exterior angle is equal to the sum of the interior opposite angles. All right, so you can use that, or you can use the angles of a triangle add up to 180 degrees. But always very important to know this theorem. well, most people run to the sum of the angles, but the exterior angle is equal to the sum of the interior opposite angles is a very important result. I don't want to, oh, not that. Let's just take some advantage of this. Normally what I do is I talk about a flag theorem. See? So you got a triangle and you got a flag. So you look for flags in your picture, like here you got your flag is this. That one. I don't know whether you can see my cursor. All right. So you look for a flag, and this angle here, the new one, is equal to the sum of the two corners. So that's the exterior angle theorem. All right. So if we go back to this thing and I stop my draw and I go back to my spotlight. Oh, this guy is still around here. Let's just get rid of him. You can see I'm getting a little bit more professional here. My wife says I'm becoming a IT genius. Oh, okay, now here we are. Right, so you got this is 20, this is 100, and therefore, but the exterior angle theorem, this whole thing is 120. So I'm using that now. 2x, x plus x is 120. So therefore, x must be 60. So we're using the flag theorem, and the exterior angle is 20 plus 100. The next one, when a number is added to 1/4 of itself, the result is 30. What is the number? Right, so here you've got a first problem involving an unknown quantity. And whenever you have an unknown quantity, it's always prudent to give a name to that unknown quantity. You can call it whatever you like, but give a name to it, and then try to create an equation involving that symbol or that unknown quantity. And then you use the knowledge you have about equations to solve for that unknown quantity. That is the strategy. Give a name to it, search for an equation. That is the tough part. And then solve the equation. 3 stages. So the unknown quantity, we call it x. Now you translate the problem. It says that when the number, which we're calling x, is added to 1/4 of itself. So we're calling it x. So 1/4 of x, you're adding these two. So x added to 1/4 of x, the result is 30. So that gives you an equation. X added to 1/4 of itself gives you 30. You have an equation involving x. Solve for x in the usual way, right? And you will get the value for x is equal to 24. I'm not going to worry too much about that because that's a very elementary problem to solve for that equation. So the number you have is 24. It's nice to test it out to see whether it actually works, right? If your number is 24, 1/4 of 24 is 6. So when you add 24 and 6, you get 30. So that's a way of checking to see whether your answer is right. Go back to your problem and put your answer in there and see whether it works. If it doesn't work, go back and check your calculations. Right, now we got on to the next problem. This problem here, it tests your knowledge of coordinates, plotting coordinates in the Cartesian plane. Now by Cartesian plane, you mean that you have two lines which are perpendicular to each other, and each point is given a pair of numbers which are obtained from these two lines. So you have these two lines like this, vertical and horizontal. We normally call this, let me get my spotlight on. So if we call this horizontal line, normally we call it x, call this y. You can name it anything, u, x, px, You can call this the u-axis and the p-axis. But what is important is that this horizontal axis gives you the first coordinates. Here you got 1, 3, and 5. This thing here gives you the first coordinates, which means that this one here is 1 unit away from this line here, horizontal distance from this vertical line. So somebody is, will you please take your drawing object out and erase that? Please don't do that. You're wasting my time here. Whoever did that. Okay, let's get back to this. Okay. So this is the x coordinate and the y coordinate. X, the one says the distance from the vertical line is 1, and the 2 says the distance from the horizontal line is 2. So this part here is 2 units, and this part here is 1 unit. This is very, very important. You might think that I'm saying something which is trivial, but whenever you have coordinates, you must always remember the geometric meaning of a coordinate. That the first coordinate gives you the horizontal distance from the vertical line. So even if I come down here, the distance from here to here is 5. It must be vertically down. It's 5, and then that's the horizontal distance, and the vertical distance is 2. Many people, I think some of you guys might have learned it like this. What the teachers do is they do this. They draw that line. I don't do that, because that doesn't tell me much. What I do is I come down to the x-axis vertically, and then I measure it. Then I know that I am 3 units from the origin, and then I move up to that point by 6 units. So to get to this point, you start from the origin. That's why this is called the origin. You move horizontally in a direction, and then vertically in that direction to get this. But from the origin, you could move in either one of 2 directions. You can move to the left, to the right here, or to the left, or up or down. So that is how you get your signs. If you go to the left, it's negative, and if you go down, it's negative again. I'm sorry I am saying this, because some of the grade 10 students might not be fully conversant with this. I know, because my granddaughter is in grade 10, and I had to take a long time to explain to her this thing. Okay, so let's get back to this. So when you actually plot these points, you will see that as far as B and C are concerned, they've got the same vertical coordinate, or the y coordinate, which means that they are, both of them are at the same distance from the horizontal line, which means that this line here is parallel to that. So, and then when you look at the other one, A3 is 6, you will see that the 3 is halfway between 1 and 5. See? So that is why this thing here is halfway. This triangle is actually isosceles, because this 3 here is halfway between 1 and 5. So therefore, this thing here must be equal to this. Okay, and this entire line is 6. And you want to find the area of this. Well, now you know the length of this. To find the length of this, you have to move from 1 to 5 to get to that. So there's 4 units here. And here you have to move from 2 to 6 to get to that. So you have to traverse 4 vertical units. So the height of this triangle is 4, and the base is also 4, because you're going from 1 to 5. So the base is 4, the height is 4, and the area of a triangle is half base times height, and there you have it. It's half 4 times 4. So when you plot the points, you can see you can work out the area very quickly, because you could work out the base and the height quickly. Okay, we're going on to problem 8 now. The average of 4 consecutive odd numbers is 32. So let's understand this question. You are taking consecutive odd integers. So you're going through the odd numbers, 1, 3, 5, 7, 9, and so on. And 4 consecutive odd numbers. Consecutive means the ones which they are next to each other. 7 and 9, 7, 9, 11, 13, those are consecutive. Okay, so you know what the odd numbers are, but you don't know what they actually are. Now, what is the largest of these integers? Well, there is really one unknown in this problem, because you can give a name to the smallest of the odd integers, give a name to it. And after that, since it's consecutive, you can name the other ones very quickly, because you have to add 2, and then add another 2, and add another 2, and you will get your 4 integers in terms of that name that you give. Now you've got only one unknown, and then you can work out the average of those 4 numbers. To find the average, you add them all and divide by 4. And once you got the average, you have that average in terms of x, but now that is equal to 32. There we have it. That's your equation that you're looking for. So I told you, when you need an unknown, and you need to get an equation, and then you solve. There is another way of doing this, where you actually think of the numbers, you imagine the numbers on the number line. Now look, imagine the numbers on the number line. You got 32 on the number line, and you got an odd number just before it, another odd number after it, and then you got another odd number here, and you got another odd number here. And these 4 are consecutive odd numbers, because 32 is even, you see. So this number here must be 31, and this number here must be 33, right? Because they are odd numbers. And this will have to be 29, and this will have to be 35. So the largest odd number is 35. Right? That's a very much better way of doing it. That's what I like about these Olympiad problems. You have to think of nice simple ways of doing something which looks rather complicated. So you can do this thing without any excess, by just understanding what average means. Average means is right in the middle. It's slap bang in the middle, this number here. So you have these other numbers must be on the same distance from 32. That must be the same distance from 32 for 32 to be right in the middle. So that is how we calculate this thing. And you get 35. But then if you want to do it like the way I told you earlier on, right, you can say let the smallest odd integer be x, then you add the 4 and divide by 4 to find the average, and you say, okay, this is the average, but I know it's 32, I have an equation. And on this side, I've got an unknown, I've got an equation, solve. To solve for this thing here, you get rid of the denominator, multiply by 4 on both sides, and you get 128. And if you add you get the numerator you can group together the like terms. 4x's plus 12 equals 128. Solve for x. X is 29. But remember, the problem was to find the largest, so you need to work that one out. That is how you get 29 plus 6. You come back to 35 after a long haul, right? The first one was very much faster. But anyway, this tells you that you can always get to the answer without too much of thinking. That's the nice thing about this. But here, you do problem solving. This is problem solving. Okay. All right, now we get on to another geometry problem. So it says here, it's asking me if I'm running out of time. Yeah, so we just got a few minutes. So let's just go on with this one. When it switches off, remember, I'm going to come on in 5 minutes. You can also leave the classroom if you want and come back to it, or you can switch off and you can connect with the link. The same link will bring you back to this page, to the meeting. So I'm not very familiar with those things, but hopefully you know what to do. So here you've got this triangle. It says that HA equals HR. So in other words, you got this triangle here is isosceles. The two sides of this triangle are equal. And you know, when you got an isosceles triangle, then the angles opposite the equal sides are equal. So this HR, the angle opposite it, is this entire angle here. That angle is equal to the angle opposite this one, which is this entire angle. So these two angles are actually equal, so that you know, because HA equals HR. So from that piece of information, that is the conclusion we made. Now, they say angle AYR is 130. So this guy here, AYR, this is 130. And they also say that HAY, hey, is 40 degrees. So this guy is 40, this is 40. All right, so whenever you got a geometry problem, you take all the information and you put it into the picture, and then you use the picture to calculate whatever you require to. Remember, the problem is, what did they ask us to calculate? I've forgotten. HYA. So you need to calculate HYA, that one. Oh, I didn't join it, so I should have joined this thing. So we needed to join it. Draw. Hey, this is fun, you know. I didn't know about. Once I went to some school and they gave me a smart board, and I said, no, I don't know how to use it. Felt rather bad. I thought probably the board was much smarter than I was. Anyway, so if you join this, then we are looking for this angle here. That. All right, now we said before that this whole angle is equal to this whole angle here. So if this is 40 and this is 40, right? Now these two angles would then be equal, because the whole thing is equal to this whole thing here. So what are these two equal to? They are equal, but the third angle is 130, and these two angles which I'm pointing to are equal. They both add up to 50 degrees, right? So each one of them will be 25. So we can calculate this to be 25 here. And if that is 25, so we can see what this yeah. Actually, it's a kind of a it's a cheating kind of a problem. You see, yeah. The fact is, let me go on with this. You got 25, so you know this whole angle is 65. This is 65. So 65 plus 65 is 130. So this entire angle here is 50. Now you suspect that these two angles are the same here. Looks as if they are the same, but you don't know whether they are the same. We'll come back to that. So this will have to be 25, and this will be 40. So 40 plus 25 is 65, and therefore you can calculate this angle because it's 180 minus 65. So the idea is you got this is 40, and you try to get hold of this angle here. If you can calculate that, then you can calculate this. So we said it's 105. You take it away from 180. So 65. You take it away from 180 and you land with 115. So that's the answer. Now that's a very long way of doing it. The fact of the matter is that these two will be equal, you see, according to this picture. Now, why are they equal? Why are these two angles equal? If you know that these two angles are equal, then you can say 360 minus 130 gives you the sum of these two equal angles, and that's 230. 360 minus 130 is 230. So these two angles add up to 230. So each must be 115. And earlier on, I kind of smiled. I said, actually, it's got nothing to do with the 40. Without the 40, you still have 115. So this 40 is really it's not really necessary to give this angle here. Regardless of what this angle is, as long as these two are equal, then you will always get that these two angles are 115. Now, what is the reason for that? The reason for that is that as long as these two angles are equal, then these two angles will be equal. You compare these two triangles. These two triangles here, HYA and HYR, are congruent. That is the thing about this. See? They're congruent. But actually, it's not quite clear why they are congruent. So maybe you have to go this route, because you got side, but the angle is not included. You got that guy there. Right, so it's not an included angle. But then you need to know that this equals this. Of course, you can say this equals this. If these two angles are equal, therefore these two angles must be equal, because the original triangle was isosceles.
Prof?
And that side was side. Okay, so you've got that this triangle here, this equals that equals that. These two angles are equal. Triangles are congruent. Therefore, these two angles are equal. You can't just say they are equal. They look as if they are equal. A lot of people get the answer right because they'll just make the wild assumption that these two are equal, but because the picture is so accurate, they can justify to make that, and they'll get to the right answer without knowing why. But you have to, when you're in grade 10, you must explain why. These two triangles are congruent. That's why these two angles are equal. Right? Very important to prove that they are congruent. And to prove they are congruent, you've got two sides and an included angle. Okay, I've got just under 2 minutes left. You've got two sides and included angle, and therefore they are congruent. Therefore, these are equal. You can go on with that. Okay. Okay, the next one
Prof?
is anyways. Yes. Oh,
Sorry, someone just wanted to
I'm
check.
sorry, I'm just going on ahead without even asking you guys whether you understand it. Sorry about this. Okay, right, let's just stop there for a moment. We've got just a little bit of time. Yes, Shiva. What's the question?
Someone wanted to ask, weren't they looking for a different angle? They were looking for AHY, not HYA.
Oh, I see. All right, but whether you read that angle as AHY or HYA, it's the same thing. Sorry, maybe I was looking at the wrong one. Let's go back to this, and your question is HYA. HYA is the same as AYH. It's the same angle. So this is the angle that I was calculating, and this is the angle which is 115 degrees, the one that I'm pointing to. Does that answer your question, whoever it was?
They were asking AHY.
Oh, I see. Was that the question, the original question? Okay.
That's what they're saying on the chat.
Okay, it doesn't really matter. So if you got AHY, you can do. We did calculate AHY. Remember, we said it was. We had this is 40. We said these were 25 or something. Oh, okay. But we can calculate all the angles. If I calculated the wrong angle, it doesn't really matter. But all the angles can